Okay, good afternoon, everybody, and welcome to the 10th session of Sunoikis Digital Classics Summer Semester 2019. Today, we have a session about digital representations of ancient dates, and we have different speakers. We have Gabriel Bodard from the Institute of Classical Studies in London, Frank Grieshaber from the Heidelberg Academy of Sciences and Humanities, Tamara Kalkhitashvili, I apologize for my mispronunciation, from Ilia State University in Tbilisi, and myself, Monica Berti. So this time I'm also presenting. And this semester we decided to include a session about ancient dates, time and chronology, because, well, this is well, an interesting topic, a difficult topic, and we began to discuss this a few years ago in our community, specifically for representing ancient dates and times in a digital environment. And of course, today we can't cover many aspects in one session. This is an introductory session focusing mainly on digital aspects. But now I think I can presenting, and I try to share my screen, and then you can tell me if you see the slides. So,
yep, it's good.
Okay, it works. Excellent. Thank you. Okay, so here you have the first slide. So the outline for today. So the idea is to have an introduction, a very brief introduction about chronology and dating in ancient world. Then we have different case studies concerning prosopography and epigraphy. We will discuss then how the TI, the text encoding initiative, addresses dates, and then we have a very few words about name entity recognition for date expressions, and finally we will talk about Godot, which is basically a gazetteer of calendar dates. Well, for the introduction, so first of all, dating in ancient world. Here, if we want to summarize the current state where we are today, so we have three different aspects. First of all, in the last 2 centuries, we can see an increasing scholarship concerning dating in ancient world, because we really have a lot of bibliography, an enormous amount of work. But the second aspect is also that we have increasing evidence, in the sense that now we have new texts, especially inscriptions, papyri, but also other texts were reread, renumbered, republished. And this is a difficult thing about this topic concerning dating and chronology in ancient world, because we have really to combine evidence and scholarship, and many times in order really to get a sense of what we have in our ancient sources, we have to read a lot of bibliography scattered in different books and papers. So these are 2 important aspects. And the third aspect, of course, which is fundamental, is that we have to combine basically 2 different dating systems, because we have important differences between ancient and modern dating systems. In order to understand ancient dating systems, we have to convert them into modern dating systems. So that's why we can say that we have a distance between evidence and statement, in the sense that, first of all, we have this distance because we have really, in order to understand and find information about our evidence, we have to go through a lot of scholarship, and then we have this distance in the sense that, of course, we have to convert to understand ancient dating systems. Well, the question, of course, here is how are we able to date the events of ancient history? Of course, we have in ancient history events in our handbooks for ancient history. We have many dates, we have descriptions of events, but in order to get these dates, of course, there is a lot of work. And then still we have many questions and big ambiguities about dates. So chronology is still uncertain for many events about, in general, ancient history. history. And as I was saying before, first, to answer this question, we have to understand the calendar systems and their time reckoning. And the question today, this is of course a big question, but the question we have today now is also how do we represent this data in a digital environment? So we have a further question and further issues. Well, if we want to define time and chronology, time is the proper dimension of history, and chronology enables us to state this time interval between historical fact and ourselves. And of course, again, as we were saying, we have to convert these chronological indications in our sources. And now we also have another aspect, how we do convert this information into a digital format, into a machine readable format. And today we will see examples. And basically what we need today is to convert the chronological reference that we have in our sources into the Julian dates of our era that we are using. And also the device of counting backward from the birth of Christ was used firstly in the 17th century, and now we use it from the end of the 18th century. So this is the convention we have for dating events before the birth of Christ. Now, well, I have really two simple examples concerning Greek and Latin sources. Of course, we have many different systems in different cultures of the past, in different languages. The focus of Sunoikis is on classical languages, by which we mean Greek and Latin languages, but of course, we're interested also in other cultures and in other languages. Here we have two simple examples from two different sources in Latin and in Greek concerning two possible dates. The first one is about the death of Horus, and in this sentence we have this expression, Horus died on the 5th day before the calends of December. And here, in order to get a date, we have to calculate so 5 days before the calends of December, which is the first day of the month. And this calculation is inclusive because we have to calculate the 1st and the 5th day. And here you can see basically the solution. Another example is an example from Thucydides, where we have a reference to the foundation of Gela. And here in Thucydides we have this relative chronology because he tells us that Gela was founded in the 45th year after the foundation of Syracuse. And so, thanks to this, we can get a date using, of course, also other external sources, because especially for relative chronology, we also need other external sources to get an absolute chronology. So these are two examples where we have to convert ancient systems into modern systems, but later we will see other examples. I'm briefly referring to bibliography concerning this chronology in the ancient world. Of course, we have a lot of bibliography, but just to understand how these topics are addressed. And here I'm referring to, first of all, these two volumes by Ludwig Ideler, and you can find them online. And this is a big work. And in this case, it is interesting because this is a handbook, as you can see, with an approach to a chronology. But the interesting thing is that this collection includes also calendars of Egypt, Babylon, the Hebrews, Arabs, Turks, Persians, so many different civilizations beyond Greece and Rome. And this is still an interesting resource. Then we have another monumental work by Ginzel, again, another handbook in 3 volumes. You can find them online, and it's still useful. And again, this is really a big collection because here again, the author includes the Far East, North Europe, and the New World. So just to have an idea how we have this approach between the end of the 19th century and the beginning of the 20th century. And they also, in these publications, they discuss many different things, as you can see, the mathematical and technical aspects concerning chronology. We also have recent bibliography, like this book by Samuel concerning Greek and Roman chronology. As you can see here, the focus is on Greece and Rome, not on other cultures. And this book is still an interesting resource dated in 1972. And as you can see here, we can have a sense when we talk about chronology. We have these different aspects: the astronomical background, Greek astronomical calendars, Greek civil calendars, and then, okay, we have the Hellenistic kingdom, the Roman calendar, well, of course, calendars in the Eastern Roman provinces, and then we have Roman chronography and Greek and Roman chronography, and here we have references to years. So how do we calculate years? And another interesting resource, especially if you want an introduction to chronology of the ancient world, again with a reference to the Greek and Roman world, is this book by Bickerman, where we have really an introduction to this topic. And I'm referring here to the table of contents because we have three main sections concerning the calendar. And here we can see different calendars in ancient Greece, in Rome, also, well, in Egypt for the Ptolemaic period. And then we have chronography, and here we refer to relative chronology, and then absolute chronology, and then the name of the year. So here we have a distinction because in the calendar we refer to the calendar date, which repeats itself periodically every year, and then we have the chronographic date, which occurs only once. Of course, we have the year. And here we have interesting thing in this second part about chronography concerning the eponymous year and so on. And then applied chronology, where we really have principles and practices and instructions on how to convert ancient systems into modern systems. But I think that now we can see concrete examples about how we can deal with ancient dates in a digital environment. And so I think that Gabriel Bodard can go on talking about prosopography, the first case study.
Thank you, Monica. Yeah, so for this case study, I want to step away from how we encode dates to think a little bit about what sorts of dates we want to encode and what impact that has on the data. And so for this very specific case study, which if you give me a moment to just share my screen, I'm going to be talking about decisions that were made in the discussion of the Snapdragon project, Standards for Networking Ancient Prosopographies. And to put that in context just briefly, the aim of this project is, as the title implies, to talk about how we should encode information relating to ancient people that is relevant for the interoperability or the sharing of data between different person data sets relating to the ancient world. So this can include prosopographies, big databases of person information and collective biographies. It can include name databases like lexicons. Lexicon of Greek personal names is an excellent example. And it can include other lists or authorities of person information, such as library catalogs and so forth. So lots of very diverse data that we want to be able to share and think about how we link that data together. I mention this because I want quite emphatically to point out that Snapdragon is not attempting to define how you should build how you should encode a digital prosopography if you were building one, but rather how to share a small subset of prosopographical and person-related information between various databases. So, Snap recommends 5 scenarios of kinds of information, kinds of activity that people might want to do, which include putting their prosopography online, about which we give very little advice, about contributing person data to this Snapdragon interoperability network graph that that people can share information between, which is the main one that we'll come back to. How we identify when two prosopographies are talking about the same person record, how we might make assertions on that data, scholarly assertions. I think this person is the same person as that, even though their primary sources are different. I think this person is related to that person. I think this person maybe didn't die in this year that the prosopography claims they did, and I have the following arguments for why. And finally, annotations on texts with these person IDs. So when you have a text that says, and then Alexander sent his messenger forth, you think, well, which Alexander in history is this? And there's thousands of possibilities. And you want to disambiguate that with one identifier from this shared person resource. But so what we want to go back to the second of those scenarios, which is that where you might want to contribute the data or the subset of your data that is useful for multiple person data sets to share. And among these various kinds of data, there's obvious things like name, attestations, relationships, other identifiers that you might use. But what these data are for is to help disambiguate between these records. As I said, there will be thousands of people called Alexander in the ancient world. Well, there will be hundreds of thousands of people called Alexander in the ancient world, of which we know about at least thousands, maybe tens of thousands. And when that name comes up, even if it's in a prosopographical record or a database record, we need something more than the name to tell us which one it is. So the date is one of the things that helps us to disambiguate that. Place, titles, and other things are also other kinds of disambiguators. But specifically with reference to date, we made the decision with this that because this was disambiguation information, the most important thing we wanted to know about the person with regards to their date is what is the span of dates during which you can more or less guarantee this person was alive. And this may not be their birth and death date, because you may not have that. It may just be, this person wrote a letter on this date. Well, we know then he was alive on this date. And presumably he was alive for at least 10 or 15 years before that date, but he could have died the next day. It doesn't tell us anything else about that person's dates. So we wanted to be very, very general and say attested date. This tells us something about this person's date, but not necessarily more. A lot of people have argued that this is not enough, that where you do have more concrete information about that person's date, you should give it. And so one possibility that we've considered is to be able to subclass this field of information where we say this attested date, where we can date them by either a century or by a particular day, and we can subclass it in various ways. And this is something you might want to discuss, in your seminar. What are the ways in which we might subclass person data? And one of these is we know the person's birth date. Another is we know the person's death date. The vast majority of people we know the names of in the ancient world, we know from their tombstones. So we know their date of death sometimes not even. Sometimes we just know their age. If we're lucky, we know both. Their reign, if this is an emperor or a king or some other very, very important ruler type person, then that information we may know, even if we don't necessarily know their full dates. We very often will know their reign. In other cases, we might just have a Florowit type date where we talk about the date when they did the important things that they're famous for. They were a counselor for these 20 years. That doesn't tell us when they were born or when they died, but that's still an important span of information to give it. And maybe it's useful to be able to say that when I'm giving you this span of 20 years, I'm not giving you their entire life. I'm not giving you their reign. I'm not just giving you the text in which they were attested. I'm specifically giving you their Florowit that's known for the following reasons. So that sort of information can be potentially useful. And it's worth comparing how other ontologies for encoding date information do these things. The periodic ontology, which I think Frank will tell you about briefly later, has an earliest date and a latest date properties, which mark the beginning and end of a period. So this sort of thing comes into this. But the important thing from Snap's perspective, and this is the final thing I'll say on this topic, is that whatever kind of date you give about a person in this data sharing ontology specifically, has to be a subclass of the general attested date property. So if I say birth date and death date as exact life date years, or just reign years, or just florate years, or just date in which we know the person wrote a letter, or whatever specific date I say, that has to be able to be degraded back, if you like, to just attested date, so that we can simply compare all of the possible Alexanders that turn up. Well, you've got an Alexander who's dated to 323. Could that be the same as my Alexander? And you can compare them based on a like, field. So if I have a florate and you have a birth date, it's hard to compare them. So we just flatten them all to just attested date, and that gives us at least something on which to compare. So that was the prosopographical perspective on what sorts of dates we need to be able to encode. I'll pass on to I think Tamara next.
Good evening. We'll be giving a very short introduction about Georgian Chronicon, the dating system adopted by Georgian kingdom in the 8th century. I'll try to share my screen. Here it is. So in the first 8 Christian centuries, the Roman Byzantine period, inscriptions were almost exclusively dated by using political or dynastic eras or the regnal years. The oldest of the Georgian written sources that are discovered in Georgia, the building inscription of Bolnisi Cathedral and martyrdom of the Queen Shushanik, include regnal year of Eros I, 18th Shah of the Sasanian Empire. It is believed that in ancient times Georgians should have had the lunar calendar, but there is no written evidence to that. Georgian dating system, Chronicon, was adopted together with lunisolar calendar at the end of the 8th century during the reign of Ashot I of Iberia, and it indicated the year 5604 BC as the date of the creation of the world, and it had cycle or moktseva of 532 years. The same kind of cycle had the Great Armenian calendar, which is discussed in the Gintel handbook of Chronology, Monica introduced earlier, but Georgian chronicles are not even this third volume of Gintel's handbook, and there are very few sources about this. As I mentioned, there were cycles of 532 years, and most of the written sources we have are from the 13th and 14th cycle, or moktseva. And the Chronicon year was starting on the 21st of March on the spring equinox, and it should be taken under consideration when converting Chronicon year to the Julian calendar, the modern date. And majority of these inscriptions include both date after creation of the world and regnal year of the Georgian king. And as the cycle or the indiction number usually is dropped, the later can be crucial for dating Georgian inscription together with paleographical characteristics. And later we will give you example of encoding Georgian Chronicon date from the inscriptions and how we then represent them in the facets. And this will be the end of my introduction.
Okay, I think it's me again.
Yeah.
Cool. Yeah, so for this section, I'm going to talk specifically how the text encoding initiative, which I think, Monica, we can assume people know what that is. Yeah.
Well, yes.
Okay.
And so if you don't know, well, the Text Encoding Initiative is a consortium for using XML for encoding documents in the humanities. This is what we can say. And we have anyway many classes on the TI in GitHub for Sunoikisis with many links and resources, just in case if you don't know the TI. Yeah.
Yeah. Hang on, I thought I was screen sharing, but I'm not yet. There, yeah. So yes, I'm going to talk about how the TEI encodes dates, with a particular focus on how TEI encodes non-Gregorian dates. So the Gregorian calendar is the dating system that we have used, at least for the last few hundred years. Some parts of the world less than that, but I think most parts of the world now would use the Gregorian system, at least officially. And there have, of course, been, as Monica was saying, many different calendars over the course of history. For encoding dates digitally, almost all systems assume the Gregorian date. And I think Frank will talk about this a bit more later as well. But how the TEI deals with this specifically is with the use of this custom dateable module in TEI. But to explain how that works, I want first to give a couple of examples of how straightforward dates, that is to say, dates that are not uncertain, dates that are not complicated, and dates that can be expressed in the Gregorian calendar, are encoded in TEI, just to show how those work. The various dating elements in the TEI, such as the element date, for example, or orig date, which tells you the date of origin of a document, have this set of attributes available to them. And the main attributes I've given you on this slide: when, which just tells you a particular date on which something happened, the not before and the not after attributes, which tell you something about the span of dates within which the event you're describing happened, which means that you have effectively you have an uncertain date, but you know that it must have been after date A and before date B, because, you know, for example, it happened in a person's lifetime and you know that person's dates. But nevertheless, it is something that happened at one point during that time. And then the third pair is the from and to attributes, which are for describing a span of time per se. So this is not one point within that span. This is when you're describing the entire span. And I'll explain this with examples. All of these, I should stress, both expect and require the ISO date standard, the International Standards Organization date standard, which expects and requires Gregorian dates. So if you try to put another date, even if it's very, very similar to a Gregorian, such as a Julian calendar date, you may find, even in some cases, that it causes an error, because they may, for example, be a year with the 29th of February in the Julian calendar, which does not have a 29th of February in the Gregorian calendar, so it may actually cause a validation error. But even if it doesn't, and the vast majority of the time it won't, you will potentially be causing a problem of expectation. If software deals with this date, it may expect it to be a Gregorian date, and if it's not, it may lead to problems, which we'll come back to in a moment. So the simple cases where we are talking about Gregorian dates, and there's not a problem caused by that, you might have a manuscript where you can simply say this manuscript was written on the 17th of January 1882, and so you can simply say the orig date, the date of origin of this manuscript in the TEI. You can say orig date, and then the when attribute has a value of 1882-0117. That's an ISO date, year followed by month followed by day with hyphens in between. You have to use the full 4 digits for the year, 2 digits for the month, and 2 digits for the day, even if the number is below 10. And then that's explicitly saying in the Gregorian calendar the year 1882, month January, day 17. And that's completely straightforward. Likewise, when we're talking about not before and not after dating. We say this particular inscription that has been found, it has text on it, and from the text we can explicitly say that it must have been written sometime between 31 BCE and 14 CE. It wasn't written continually for that period, it must have been written at some time in that period. And the reason I say that we can say this is unproblematic in the Gregorian calendar, even though at this period we'd have been talking about the Julian calendar normally, is that the difference between an entire year, 31 BCE, in the Gregorian calendar and the Julian calendar is negligible. So I'm comfortable saying that whether you think 31 BCE is Gregorian or whether you think 31 BCE is Julian, it makes no difference, because we're not talking about specific days within that year. So let's call this one unproblematic. Okay, we're talking about the Gregorian calendar quite happily. Or if we're not talking about the Roman Empire, if we're talking about geological time, we'll be using the Gregorian calendar anyway, no matter how far back in history we're talking. And the third example is where you might have a text that its date of origin actually was a constant date, a constant composition throughout the reign of a particular emperor. For example, in this case, the reign of Trajan, which lasted from 98 to 117. Again, it doesn't matter whether we're talking Gregorian or Julian. And so we say from and to, in this case, from 98 to 117 as a continuous activity. Okay, so those are the three types of dates that you can encode in TEI if you don't have any problems with dating system and there's no uncertainty or any other weirdness going on. When it's more complicated than that, as it usually is, especially working with classical dates, but with many other periods of history as well, the TEI has this mechanism, the custom dating module for encoding dates that are not in the Gregorian calendar, and they're not validated against the ISO date schema in the same way, and so you can encode a set of dates that mean something different. And the TEI itself gives you half a dozen examples in there. I have to say that I was in the small working group that invented this mechanism a few years ago, so it's please blame its imperfections on me, but obviously not any of its genius activity, which is almost certainly the rest of the working group's responsibility. So, for example, in the first example on this, I don't know how well you can read this slide on YouTube, but in the first example we have the date of death of an Arabic figure, Al-Hazan, whose date of death was given as the 12th day of Jamada Tanya in 430 AH, and that we can say is both the Gregorian date, the 6th of March 1040, and the Hijra date, the 12th of that month in 431. That presumably that's not an error, and that there is a reason why we've normalized that to 431 rather than 430, although it might be an error. I don't know. I don't remember now. But so the point is that you have both a normalized and validatable Gregorian date, and you have this custom date, which is in some other format, non-Gregorian format. And whatever the non-Gregorian format, whether it's the Arabic date, whether it's the Mayan dating system, whether it's the Egyptian dating by Pharaoh, or whether it's an addiction, those are dates that can be expressed in this custom format because they're not validated against Gregorian. Not all custom dates will have that Gregorian equivalent, of course. So these are the new attributes that have been introduced in that custom, or the first 5 of these anyway are the new attributes that have been introduced in the custom dating module, the first 7 of these, in fact. So the first 5 will be very familiar: when, not before, not after, to, and from. They all mean exactly the same as they do in the regular TEI, just they have custom added after it, which means they are not Gregorian. So you can say when, and you can give a very specific date, which may be year, month, day, but you can say that this is in the Julian calendar, which in the ancient period, if you're talking about a specific day, talking about the Julian calendar, maybe several days out from the Gregorian calendar, even the proleptic Gregorian calendar, and so it matters if you say that. You then you have these two other attributes that are made available. One is dating point, which allows you to say these dates are dates after a certain point, and this is the point. And that point may have a date, or it may just have a definition. So it may be, since the accession of this pharaoh, and we don't know when that was. So we don't care. But since the accession of this pharaoh, it's been 17 years. Or we might say since the year 2604 BCE, it was a 9-year period since then. So the dating point can reference in either of these, and dating method allows you to point to a definition of the dating method you're using in these custom attributes instead of the Gregorian calendar. So that's where you would point to something that says the Julian calendar or the Georgian Chronicon or whatever else. Worth noting that the existing attributes that already existed in TEI, calendar and period, are also useful in this case. Calendar, I should point out, describes the calendar of the transcribed content, not necessarily the calendar to which you're normalizing it, and the dating method describes the calendar to which the custom attributes are normalized. You don't need to say which calendar the regular dating attributes, when, not before, etc., are normalized to, because they're always normalized to the Gregorian calendar. Okay. So again, a few examples, just very quickly. If we want to be pedantic and we want to say the 3rd century BCE is sometime between 300 minus 300, because it's a BCE date, and minus 201, and we want to say those are not real dates. Because if I say 3rd century BCE, I almost certainly don't mean, and if I say it, that is the date of an inscription, I absolutely certainly don't mean that it could be on the 1st of January 300 BCE, but it could not be on the 31st of December 301 BCE, right? I mean, that's not a firm date. So instead, I say precision equals medium, which means these dates are essentially arbitrary rather than actually a terminus post and a terminus ante quo. So here's an example then of using the custom attributes. If I say that something happened in, and in the text we say it happened in 20 to 19 BCE, what we mean is that it happened in, let's say we're talking about consular dating, it happened sometime in that consular year, that Roman consular year, which started on the 11th of December and ended on the 10th of December the following year. So it was sometime between those particular dates in 20 BCE and 19 BCE. And those particular dates, it matters that we're not talking about the Gregorian calendar. So we say dating method is Julian. That hash there at the beginning of Julian means that this is not just a string, this is a pointer to an element somewhere that defines the Julian calendar for the purpose of this exercise. We could also say that if the text says year 11 of the Actian era, we can say this is the calendar that it's talking about, and we're normalizing it to the Julian calendar rather than the Gregorian one. So there you see those two attributes, dating method and calendar, both used side by side and saying different things, as I explained. So just a couple of examples then of mentioned dates. Here's a text which mentions a date very specifically, but we're normalizing it, as we always do with reference to ancient dates, to the Julian calendar. So we use when custom rather than just when, which we normalize it to the Gregorian calendar. And then there's dates where we don't actually know the date of something, but what it's recording is a time span. It's saying this person lived for 70 years and 9 months. And so we record this using a duration attribute. We don't know when that span started, but we know how long that span lasted. And that's again, that's an ISO defined terminology. P for period, I guess, 70Y for years, 9M for months. It's not very human readable, but it's not meant to be. It's computer parsable. This can also be used for other kinds of spans, how long someone was married. These people were married for 30 years. We don't know when it started or when it ended, but that's the general span there. So just to summarize again, here's again those examples from the TEI guidelines. Just wanted to stress again that sometimes we normalize to this because it is conventional to normalize to the Julian calendar or some other calendar rather than the Gregorian. Sometimes we do this because it is useful to be able to compare these dates mathematically to one another, regardless of their Gregorian values. And sometimes we do this because we just don't know the Gregorian date, but it is we still have numerical values that can again be compared to one another in a useful and meaningful way. So we'll come back to this again very briefly at the end, because this is one of the examples that the exercises we're going to present. But I'll pass the camera back to, I think, Tamara again for a brief example of how you might encode and then how you might display some of these dates. Tamara, I think you need to unmute.
Yes. So I'm going to show very briefly how we have encoded the Georgian Quranicon in the inscriptions, and how we then use this encoding for faceting. As we have mentioned, the majority of inscriptions preserved today are from the 13th and 14th cycle of Indiction. And here you can see the bit of the encoding from the inscription text, where it mentions Koronikonsa L.E. And as I have said, the date of the creation of the world with Georgian Indiction was 5604, and the end of the 13th Indiction was 1312. And we can guess here that it is Indiction 14 and year Le, which is numerical, it's equals 38. And we add to the end of the 13th Indiction the number of the years and get the exact date of the creation of this building inscription. We also mark up the OIT date, and we say in the metadata, in the TI header, and we indicate that there's an evidence of internal date and its precision is high. And then it results when we have encoded this way all the inscriptions we have now in our corpus. And in facets, you can see the inscriptions which has this Georgian Quranicon date with its numbers, and you can just go to the inscription and see the whole page of the inscription. That's the end of my example.
Okay, I
Tamara,
don't know, Gabby.
Quick question, Tamara. That corpus is not yet online, is it? For us to look at.
This one is not yet online. It will be till the end of this year, but we have it offline in FS. We had our own database, and now we are developing one with FS.
Cool. Thank you.
Okay, so I think it's my turn, and I share the screen. Okay, very, very briefly, I would like to talk about name entity recognition. So now we have seen the use of the text encoding initiative for using XML, extensible markup language for encoding dates. And I think this is very interesting because, as you see, we are adding another layer. So we have ancient systems, modern systems, and now we go on interpreting these dates using a specific tags, and then we have a language with documentation. So this is interesting, I think, but we are adding a third layer. Now, very briefly, name entity recognition. Name entity recognition is a part of NLP, natural language processing, for trying to extract information from unstructured data. And name entities, well, the goal, as you can see here, is to find mentions of name entities in the text and classify their types into categories corresponding basically to proper names and quantities of interest. And we can have people, places, organizations, time expressions, monetary amounts, percentages, etc. And I'm referring to this today because part of name entities is constituted also by time expressions. I have this slide and I have 3 screenshots from a recent book about name entities for computational linguistics. And in computational linguistics, so we have types with this abbreviation, as you can see, for annotating name entities, and they can be people or places or also a time and date, as you can see. And then we can have also subtypes because it depends on the data we are annotating, the language, etc. I don't have examples for ancient sources. You can see here we have examples in this slide concerning text, modern text in English. And for time, as you can see, we have different examples because we have time 8 o'clock or last night, then we have a date, the 23rd of July or last July. Then in the second screenshot, we have for time. So we have a specific subtypes of the type time for date and hour. And then we have to see if it is absolute or relative. And then in the last screenshot, we have again time, and here we have different dates, like Thursday, April 16, or 1945, the 70s, yesterday morning, 3 days ago, etc. Now, these are modern expressions in English, and there is a lot of work because we can use these labels to annotate these time expressions, but how can we extract this information from our text? Of course, we have data for English, but this is a big question, especially for ancient sources like Greek and Latin. So how can we try at least semi-automatically to extract this kind of information from our text? And again, also in ancient sources, we have many different examples for time and date. So I wanted to refer to this because in computational linguistics, we have name entities, and part of name entities is also time and date recognition, but of course we still have to work for ancient sources to try to extract this information, and then using generic labels for annotating this information, and then defining subtypes, as you could see in the TI, for further annotation of this information. So I wanted to refer to this for our current state in our work. But I have to say that for historical languages, we definitely miss basically everything. So, but now I think that we can go on with Godot, and we have Frank Grieshaber with us. So I stop sharing, and Frank, you can present.
Okay. Thanks, Monica. I will share my screen first. Okay, now you should see my first slide. Okay, I will start with giving a quick overview of two linked data gazetteers of modern historical periods, which are the Periodo and the Chronology gazetteers. And then I will present the main lines of the Godot project, which is a gazetteer for ancient calendar dates. And I will conclude with a quick view at some features provided by the new ISO 8601 standard, which has been mentioned already before. So period gazetteers. Both the Periodo and Chronology gazetteers work somewhat similar, but there are, of course, some differences. But both understand a period as a modern temporal and spatial concept. And examples for these historical periods could be Hellenism or Roman Republic or late Bronze Age. Both provide, as gazetteers naturally do, identifiers for these periods in the form of URIs or permalinks. Periodo has been around for several years now. It defines itself as a gazetteer of scholarly definitions of historical, art historical, and archaeological periods. This means that for any period definition found in any publication, there can be a Periodo identifier in the form of a permalink. So they provide bibliographical information about each period, and they provide a definition of the time span in years. And sometimes they do also provide some geographical information. Periods are collected in so-called data sets, which usually corresponds to a book or some kind of publication. And on the Periodo website, you can navigate through all these data sets and all their periods. But periods, publications can also be a controlled vocabulary from any website. Like, for example, the periodization done on the website of the epigraphic database Heidelberg, where each dateable inscription has at least one historic period, one Periodo URI assigned to it. So you can search and browse for these periods on the EDH website, and inscriptions can be grouped by their temporal footprint via these Periodo URIs. Just by clicking the link, show all inscriptions from this period. So you can see that you can use these Periodo URIs not only in epidoc files for referencing periods, but also in any database system like the EDH. Chronology has been created by the German Archaeological Institute in Berlin, and it is part of a number of web services and databases around the many projects of that institution. They define themselves as a web service that connects chronological terms like epochs, periods, and events with dating information. And it serves as a norm data vocabulary for other information systems and links them with other global time gazetteer systems. So in the end, it is embedded in a complex architecture of online services and databases. And those periods can be used to filter and browse for data according to historical periods. So in the end, you can find objects or places from the same period. They have imported existing period definitions from other sources, like, for example, the Getty AAT or the Arachne image database. They have created one own dataset, which they use for their own databases of archaeological material. In general, the data model of chronology is a bit more complex or elaborate in comparison to Periodo. Periods not only have a temporal or spatial extent, periods can be typed. For example, they can be geological or political, they can be historical or cultural. And they have a certain degree of vertical hierarchies when it comes to temporal and spatial extents. So you can browse these in a very neat timeline on the website of Chronology. Okay, so much about gazetteers for modern historical periods. Often enough in ancient primary sources like inscriptions or papyri, you can find ancient calendar dates. Usually in digital editions or in linked open data applications, these dates will be simply converted into the corresponding Julian dates, which we have seen earlier. But of course, this leads to losing information about the ancient calendar system itself and its constituent parts. So to prevent this information loss, we need a gazetteer for ancient calendar dates, and Godot is exactly that. So Godot is an acronym for Graph of Dated Objects and Texts. It's collaboration between Trismegistus in Leuven and Charlotte Rocher in London, with some support by Gabriel Bodard also. We have just finished the 6-month prototype phase, supported by the Mellon Foundation. Godot is both a chronological gazetteer and, to some extent at least, a research infrastructure where you can search and browse for data, and you can use some tools on the website. It's a gazetteer, so we have stable, citable URIs for calendar dates. We started with some sample data taken from the Inscriptions of Roman Quranic project, an online edition by Charlotte Rocher. And we have taken around 3,000 texts from the Berlin collection. These are papyri and ostraka from Egypt. We have tested some different data import options, manual data entry and bulk imports. And we have implemented some tools on the Godot website, like date conversions. We have some identifier tools and an open refined reconciliation service, and of course an API for reusing Godot data. The website is at the URL godot.date, and the main entry point for looking at data already in the database is the browse data functionality. This gives you at the top of the page a list of all year reference systems that we have in the system. So, for example, we have the indiction cycle or the Actian era. We have regnal years from the Ptolemies of Egypt or Roman emperors. We have Roman consulates and the titulature of Roman emperors also. So you choose one of these year reference systems, like, for example, the regnal years of the Ptolemies. Then you have a list of all the Ptolemies, and you choose one of them, and then have a list of regnal years. And finally, if you click one of those regnal years, you get the detailed view of a date. In this example, we have year 18 of the Roman Emperor Trajan. And you see that we already have some attestations of that date in some texts, in ancient texts. We have one Egyptian papyrus in Greek language dating to the 18th regnal year of Trajan, but we also have some attestations that are more precise than only giving the year. We have one example that dates to the 18th regnal year of Trajan, month Apollonius in the Macedonian calendar system. And by clicking on the attestations, you will be transferred to the online edition of those texts. You can not only browse for specific dates, but also for synchronisms. Synchronisms means here double dates in ancient texts. So, for example, we have a papyrus that could be dated to some date in the Egyptian calendar system and in the Macedonian calendar system. And we have a couple of dozens of synchronisms already in our database. As for tools, we have calendar conversions for the Egyptian calendar system and for Roman consuls. In this example, we have the Egyptian calendar system from the Ptolemaic period. We have, for example, Cleopatra VII, her 14th regnal year. The Egyptian month name is Hathor, and day 4. And if you click submit, you get as a result both the Julian and the Gregorian date. Another tool which you can use is the identifier tool for Roman emperors. Say you have an inscription which is broken off a little bit, and you cannot read the name of the Roman emperor, but you only have information about the Tribunia Potestas number, the imperator number, and the consul number. You can enter those numbers into this web form and get, as a result, a list of Roman emperors, which with the highest likelihood will be mentioned in that text. Okay, Godot, as I said, is an acronym for graph of dated objects and texts. Graph is the data model that we are using in the background. We have a graph database, and we transform each calendar date into a graph. As example, we have here an Egyptian calendar date, regnal year of the Roman Emperor Hadrian. Hoak is the month name, the Egyptian month name, and we have day 11 of that month. So to transform that into a graph, we start with a timeline node. That's the first node, and then we have the year reference system. In this example, the regnal year of Roman emperors. Specifically, we are talking about Hadrian, his 15th year in the Egyptian calendar system. Month is Hoak and day is 11. So we have here the complete date in a graph. And we are adding then some more information, like, for example, the Godot URI plus some additional information, plus an attestation node which holds information about the text in which the date attestation can be found. To sum up what we have already as data in the database, by manual data entry, we have several hundred inscriptions of the Roman Quranic, which Charlotte Rocher has been entered manually. She uses project-specific, tailor-made data entry mask on the Godot website. So she can now enter single year dates, she can enter titulature of Roman emperors, and some eponymous officials. Examples for bulk import, we have, as mentioned, what Trismegistus has been doing. They have pre-processing some kind of data by an NER workflow. They have exported that into a CSV file, which I can then import into the Godot graph database. And some other examples for using APIs of content providers are the Epigraphic Database Heidelberg and the online coins of the Roman Empire project. Okay, that's more or less what I wanted to show about Godot. I will conclude now with a quick look at some of the new features of the ISO 8601 standard. We have already seen several examples on what you can do with it by now. Lately, a new standard has come out, which offers quite a number of interesting new features for digital humanities, because now you have the option to encode fuzzy dates, which wasn't easily done in the old version. There's one caveat. The following is based only on a draft of the standard. The final version came out only very recently, and I haven't seen it yet. But I wouldn't expect many, if any, changes. Like I said, this new version offers new features for dealing with some more fuzzy dates. We can deal now with precision, with uncertainty, with unspecified digits. I will show now some basic examples of these new features. First one is qualification of a date. You can add additional qualification characters to components of an ISO date. So you can add a question mark for uncertain, a tilde for approximate, and a percentage character for both uncertain and approximate. Important here is the position of the qualification character within the date. It could be either to the left or to the right of a component of a date. one example for immediate right of a component could be having the year 2004, month of June, and day 11, then the percent character. This means this date is uncertain and approximate. The full date is both uncertain and approximate. It refers to all date components to the left of this qualification character. If you add it to the left of a component, only that component is either uncertain or approximate, or uncertain and approximate. Then you can have time intervals. The time interval, both the start and the end are dates. They cannot be intervals themselves, which would add some more flexibility, but you cannot do that. Start and end dates are divided by a slash, separated by a slash. The most basic example would be to have 2 years, like 1964, 2008. But you can add also month and days. You can mix the precision, having one only the year, and the other would be year plus month or day. You can leave either the start or end open by leaving it blank. And you can also add some of these qualification characters, which I just mentioned. Then there are sub-year groupings, like seasons or quarters. For using those, you replace the month number with one of the following numbers shown in this list. For example, to model the second quarter of 2001, you enter the number 34 as or the position of the month. And then there are unspecified digits, which you can often find, of course, in ancient sources. In these cases, you insert the character X on arbitrary positions within the date. And so you can model, for example, a decade very easily. And yeah, that wraps up what I want to show about gazetteers for periods, for ancient calendar dates. And I've shown some of the new features of the ISO 8601. You have to know, of course, that this standard is very new, and there are no databases yet that use these new features, and there are only some programming languages that at least support some parts of the standard, but eventually this will come in the next years. Okay, that's what I wanted to show.
Okay, thank you very much. And I think, yes. We wanted to comment on the exercises, maybe.
I have a very quick question for Frank, if I may, because before I forget, because it follows immediately on his last couple of slides. In the encoding for time intervals, where you gave the example of how you can leave the date off the end or off the beginning.
Yes.
If you do that, if you first say 2008 / nothing, does that mean from 2008 until the end of time, or does it mean from 2008 to unknown?
I think it's more or less unknown, because end of time, yeah, well.
Or no, to now, or something.
Now, of course, can be a bit difficult or dangerous also. Yes, so it's leave this open.
Yeah. So you're saying is the only claim I'm making is that it started in 2008.
Right. Yes. Exactly.
Yeah. Thank you.
Yeah.
I don't know if we have questions. I know that we have students from our courses in Leipzig, so don't be shy. If you have questions, you can ask questions. I understand that the topic was, well, it's difficult in the sense that chronology, in any case, is difficult, but now we have, I have to say, wonderful resources, as you can see. There is a lot of work behind the TI, behind Godot, Periodo, so really, in the community, we are building a lot of work for annotating very complicated
data. Maybe we can comment on the exercises, because in GitHub we have at the end of the class outline we have links to these resources, we have readings, so if you're interested in the topic, and we have many readings, and then we have a last part with exercises. I don't know, Gabby, if you want to comment, and Tamara also.
Shall I quickly talk about the first exercise?
Yeah, sure.
And then Frank can quickly talk about the second exercise, which is Godot based. So let me just quickly. Can you see the exercise text now?
Yes, yes.
Yes. So this is from the bottom of the session page in GitHub for this session, and so this is the exercise that Tamara and I wanted to propose you all to try, and this is simply to find here there are 5 examples of dates which we've expressed in prose, if you like, and we wanted you to try to encode in TEI using the dating module that I showed you earlier, and the custom dating module where needed. Try to encode these 5 dates. Some of these dates require you either to know off the top of your head the reign about Constantine the Great, which I don't. I would go to Wikipedia and look it up. So if you know, fantastic. If you don't, go and look it up. Some of them require you to understand slightly more advanced questions. So if something is a certain number of years since the creation of the world, you have to understand what the author understood by the creation of the world. And in the last one, it's one of the Georgian dating systems of the kind that Tamara gave, and so we've given you a bit of help. So behind this text at the bottom, expand. If you get stuck calculating what the Gregorian date would be, you can click on that and it'll tell you. But I hope most of you will have fun and figure it out yourselves, because I think that's a fun thing. So in each of those cases, use an ORIG date element. Decide whether you want to use when, not before, not after, from, to attributes, whether or not you need to use custom date attributes, whether or not you need to use precision to specify something, and so forth. And have a go at encoding this. You might also find that the extended date time format that Frank has just described might also be useful to use inside those dateable attributes to help you encode some of the uncertainties recorded in here. So this should be fun, and you will find if you bring your answers to your seminar that some of your colleagues will have different answers, and neither of you are wrong, because there are interesting ways to encode this sort of thing. So I think yeah, try it out. I'm trying to stop screen sharing, but lost the button. Right.
Okay, thank you. Then we also have a link to a Google Doc with other exercises. I don't know, Frank, if you want to comment on it.
Yeah, the basic idea of the assignments for Godot are to be familiar with the Godot website. I have links to 2 Greek papyri from Egypt, which can be dated, and I have added the English translation of the date part at least. You can find English translations of the whole text in the book Select Papyri, and the questions here are the task is to find the Godot URI for these 2 dates, and so you have to use the Godot website. You can use the browse data functionality of the website, or in the second case where we have Roman consulate, you can use the identify Roman consulate tool on the website and find out the Godot URI, and then you can maybe encode the complete date in TI, also in Epidoc. Yeah, that's the basic idea of the assignments.
Okay, excellent. Thank you. And we have a question in the chat in Google Hangout. So Anisa is asking if Recogito will provide data annotations one day. Well, as for now, Recogito, which is an annotation tool, web-based platform. For annotations, we can annotate places and people. I don't know if we want something like that, or well, or we can have other tools.
Well, so there's no representative of Recogito in the group right now, but I can try to guess at an answer based on the answer to a similar question that I asked the Pelagios folks about other kinds of things that we'd like to be able to annotate in Recogito, such as people and so forth. Which is that, so there's two parts to the answer. One is that Recogito is open source software, so anyone can take it away and add a new set of functionality to it. And so there's a side project, for example, who are attempting to add more information about person annotation to Recogito. So it would be very straightforward to do the same to add place annotation to Recogito. And I think that would be really cool. As to whether the Pelagios team themselves would do so, given that they have just under 6 months funding left, I think the answer is quite clearly no, not right now. But that doesn't mean that they wouldn't in the future with a collaborative project. And that they would certainly welcome a partner project who would be interested in doing so, and they would support in all sorts of ways, both in helping to get funding to put together and also in helping with advising on the programming of that to get that to work. The third answer that they would give is that it is, of course, possible to annotate dates in Recogito now. You just can't. You just have to use their default annotation. You double click. You highlight the span of text that you think is a date. And rather than saying this is a place or a person or an event, you just say in plain text, this is a date and this is what it refers to. And so it doesn't really, and you can use tags if you want to specify the calendar and things like this, but it's fairly generic, but you certainly could, you could still do that, and then you could use those annotations if you export them and use them in your own workflow. As to whether we could build some of the NER for identifying dates into Recogito, that would be a new project, and I think that would be a really cool project. And I think at least 3 of the people working on that project, or the people who ought to work on that as yet imaginary project, are in this hangout now. So I think we should, if people think that's a cool idea, we should discuss it. But we'd need at least Rainer Simon to join us, if not others.
Well, yes, and so there are definitely is something that the community is thinking about. Also, for in Recogito, we have an automatic name entity recognition as for now for modern languages, German, English, French, Spanish. There is a beta version for Latin, because now there are experiments for automatic NER for Latin, but more for people and places, of course. But this is the interesting thing, because in Recogito we annotate people, we annotate events, so we should add another layer, because as we know, people can be used for dating for dates. We have seen before. So this is an interesting thing. So we add another level, because I don't know, archons or consuls are names, but they were also used to date. So here we have many different issues. So do we want another layer, and how do we express it, etc., etc. But definitely that would be super cool to have also this. We have other annotation tools, for example, Weban, Inception, where technically we can definitely annotate, at least manually, also dates using these labels from computational linguistics. But again, so how can we connect these resources? And again, how can we do that for sources in the original language, not in translation? But anyway, so we have many, we have desiderata, I have to say, so for the future. So now is 6:20 in Leipzig. I don't know if we have other questions. No questions? Okay, so our time is over. And well, next week we will have another session about, the title is From Annotated Text to Vocabulary Exercises. And we will have Neven Jovanovic from Zagreb with his students, so they have been contributing a lot to Sunoikis, and I think they will talk about annotations for Latin. So if we don't have other questions, so first of all, thank you for, well, so thank you to my colleagues for this session. It was great because we could finally work together on this topic that we are interested in. And thank you all for listening to us. So you have the class outline, and we are going also to put the slides online. So thank you again, and see you next week for another session of Sunoikis, and good night or good afternoon for other people in other time zones. Okay, see you.
Thanks a lot.
Bye.
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 Goodbye.